trigonometry, but before the unit circle, we get to just chill with angles for a bit. How hard are angles?
Not that bad.
Hopefully not that bad. Way back when, did you ever use something called a protractor?
Yeah.
It's like a little half circle with a ruler on the bottom, right?
Yes.
And the little protractor had little baby degree marks, right? What is this, approximately, as far as measuring?
Right angle.
What's that?
180.
180. What's this?
270.
How do you remember that? 918, sorry. 9, 18, 27, 36. Aren't they just multiples of 9? Yeah? Okay. So we have 90, 180, 270, 360. Those are degrees. But 90 what? Degrees. But what are degrees? Awkward. Something that's so just natural. Right? So natural. It's whatever. It's 90 degrees.
Measurement.
It is a measurement.
Angle.
Oh, well, okay, yeah, that's an application, but this is a completely different degree. You could say that 1 degree is 1 angle and 90 of those 1 degrees, but what does 1 degree measure? How big is 1 degree? It's tiny, right? On your protractor, wouldn't it? Can we think of protractor? Wouldn't it be 1 little baby tick mark?
Yeah.
Right?
Yeah.
Which is the smallest sliver ever. Now, ironically, 1 degree can get split into 60 minutes, and that can get split into 60 seconds. Why would you ever split a degree? Like, it's 1 little thing. But what happens if that 1 degree is taken out farther and farther and farther and farther and farther? What if you were starting from the North Pole, and you were standing, literally, on the North Pole, and you were to have 2 protractors, right? Well, here, put the North Pole, put the center of the 2 protractors right here. How big would 1 degree be? Tiny. 360 all the way around. But what if you took those degrees and drew them around the entire globe? All the way to the South Pole. Oh, hey, they're called longitudes. And if you go to the equator, how far away are each of the longitudes? A lot bigger than the little baby tick mark way back up on the North Pole, right? You have the longitudes that go long and the latitudes that are like a ladder, right? No one ever remembered it that way. Longitudes, and then you have the latitudes. Anyway, those are measured in degrees. Global positioning systems, GPS, measured in degrees. So maybe 1 degree being cut into 60 minutes, being cut into 60 seconds. Why did they make it 60 and 60? That's confusing. Wait. They're relating it to time. Yeah, they're relating it to time. It's not time, but they're relating it to time. Weird. Anyway, coming back. Maybe there are things about angles that you don't know. So let's talk about what you probably already do know. If you are starting on the positive x-axis, which is the first step of standard position of an angle, so the initial side is on the positive. Guys, we're not going to physics yet. In physics, you can have like this model diagram where you're drawing the XY wherever you want it, and we'll see it in chapter 6. So I'm not telling you where this positive x-axis is. I'm just saying normally when we measure angles, not necessarily applied to physics, we measure from the positive x-axis. And we rotate counterclockwise. To be a positive angle. I don't want to put degrees because we're trying to do degrees or radians. Let me just say 0. Wait, who's this? What is that? Theta. It's a Greek letter. It's a circle with a line through it. Greek letter? Why are you doing Greek letters? In geometry, we did capital A. Further you go in math, capital A has lots of different meanings already. Not that you won't still see capital letters, but usually Greek letters, or more frequently I should say, Greek letters are used. Oh, hey, frequently used Greek letters. There you go. So theta, a normal positive theta would measure counterclockwise. Oh, wait a minute, hold on. So I'm going to go ahead and double space real quick because we need to talk about what if you're going the other direction. So what if you're going clockwise? Well, guys, if positive angles measure up and to the left, what are negative angles going to measure? Yeah, exactly. So clockwise angles are just going to be negative. Does anybody just, I don't know, with any real world experience in the business world know why I'm making one black and one red? Anybody's parents in accounting? Have you ever heard anyone talk about being in the black or in the red? Kind of doing good or bad, talking about your finances specifically. If a business is in the black at the end of the year, why is it called Black Friday? You guys know what I mean after Thanksgiving, Black Friday. You're trying to get profits to overrun your costs. Don't a lot of businesses need to produce and actually get merchandise out there before it can be bought? Haven't they spent before they've made? Now, once you have a certain, I don't know. In startup companies, they're always talking about once they can finally go into the profit, get out of the negative, get into the positive, getting out of the red and into the black. In your accounting, red is usually the debts against you or the credits against you. Debits are actually putting money in. Anyway, if you're in the red, that means you're in the negative. So you're owing money. If you're in the black, that means you're in the positive. You've actually finally made money. So negative angles go that way. Positive angles go that way. Oh, here we go. Last one. And they have, let's see, this is the initial side. I didn't keep on labeling. This is the terminal side of this theta, or this is the terminal side of this theta. Terminal, terminating, ending. Like a beginning side, ending side. And then it has the vertex at the origin, which is probably pretty basic as far as you guys thinking, but there we go. There you go, and then Greek letters. Now, some of you already saw the Greek letters, some of you weren't paying attention, so when everyone freaked out, you're like, what's the big deal? Yeah, the Greek alphabet. Why would I have you, that looks fun, have you write the whole thing when I only want you to really know the highlighted ones?
Wait.
Gotta get started. There are capital letters, there are lowercase letters. Some of them are more interesting than others. Because I want you to read or be able to read all the sorority sweatshirts when you go to college. Not really, don't really care less. Not to say there aren't possibly a benefit or two to joining a sorority that might have certain ties with certain people in the business world or the medical field, etc. But usually the temptation for what else goes on in those sororities makes it not worth it. And they're much wiser, smarter. Anyway, when I showed honors pre-cal, they were like, yeah, I can go to college someday. I'm like, not the point. Well, yes, it's the point, but not what you're thinking. Anybody ever heard of gamma rays?
Yes.
Yeah. Oh, hey, Greek letters are used in future sciences quite a bit. Gamma, I'm not having you underline it or highlight it or memorize it, but gamma rays. Epsilon, not a lot. Lambda is used in a lot of, lambda and mu actually are used in a lot of physics formulas. We have, of the other ones, not many of them are used in at least common equations that are not highlighted. Deltas and betas and alphas and thetas and pies and sigmas and, well, sigma, you guys might have seen him on a PSAT practice, right? Isn't he just a summation? Interesting. Alpha and omega, well, I mean, that's in the Bible. But even though you might, you see nu every now and then. I just want you to have some sort of understanding. Now, guys, do you necessarily have to make these gorgeous? No. But some of you might try. I have some hands all over. Nikki.
So, if you're writing a problem by hand and then you get a squiggly, do you have to write the squiggly?
Well, no. It's a great question. Actually, Adam Tilbeck asked this the other day. And they actually, I think they were referring to something that came up in AP Chem or AP Physics. I forget what they started going off. Or was it in BC? No, it was in AP. If you ever don't like a variable in a problem, you can technically change it. But you have to say something like, if there's a theta and you don't want to use a theta, you have to change it with this little statement. Does that make sense? Then from there on out. Now, you guys haven't seen me do that one, but you have seen me do that with another type of problem. Let me go and do this and do this. You guys can keep writing. But do you remember a certain bonus on a certain test? Yesterday. If it was the bonus on a test. I actually don't remember.
Yeah, there was.
It was? Where you might have had something like, right? Is it not? It might not. Oh, it was a word problem. That's right. I gave you I chose to not make it a long answer. I made it the bonus instead, so you didn't have to do the paragraph long. I forgot. This is a topic that I said would only be in the bonuses. You wouldn't have to study it. And to be honest, I made you guys not have to do the big old paragraph one in the normal long answer. That's right. I made it the bonus instead. But when I did this in notes, you remember how I let some of you rewrite it? Because the e to the x was confusing. So if the Greek letters are confusing, check it. This allowed me to do something like, and you're right, it does make it more understandable. In calculus, there's this crazy formula called the definition of the derivative, where you guys might recognize pieces of it. Ooh, f of x plus h minus f of x all over h. Didn't we do that already? Who's that? And who's that? Don't think about it. But long story short, a lot of people don't like this delta x because it's confusing. It's different than, but it has an x. And so there's a variation that a lot of kids like to use. And I just make them state this first. And then they can make it a little bit more understandable. Anyway, Nikki, that was a long answer, but because it was a good question. But yeah, just write that little let statement. And Mrs. Leon would totally approve as well. I think it's in physics where she does that. Sorry. Hold on. For us to get ready for the next page, I need you guys to think about how rulers are made. Rulers, tape measures. Have you ever gotten your measurements done for like a certain dress or a suit or something like that? Those flexible measuring tapes. How are rulers made? Greek alphabet. For our purposes, to be honest, I'll probably be using theta and alpha. Oh, hey, didn't you see delta in the whole delta table thing, like the change in table? Or this little formula, delta y over delta x? Anyway, let's keep going. I asked you guys to visualize something as you got to this page. Do you remember what I asked you to think about? Rulers, just in general, right? Okay. So with rulers, question: what do tick marks on rulers stand for?
Depends.
Depends. What do you mean depends? Oh, maybe centimeters, but what else might it stand for?
Inches.
Inches, millimeters,
That's what they said.
tenths of inches. Nicely done. The tick mark is dependent on whatever it's measuring. Sure? Okay, so when you have a ruler, typically, yes, you have inches on one side, centimeters on the other. Okay, you have the English metric. Let's not get into a debate. No drama today. But it's not that kind. Have you ever wondered what a radian is? Well, you hadn't wondered what a degree was either. But anyway, so if a degree is 1/360th rotation of a circle, that's one way of defining a degree. It's 1/360th of a rotation of a circle. Which at the equator could be a whole lot huger than the protractor at the North Pole, but either way, it's still 1/360th of the circumference. But as far as the rotation, what on earth is a radian? Some of you guys have memorized that radians have something to do with pi. Last year when you were filling in that circle thingamabob for Mr. Che, the unit circle, didn't he have you do, I think, degrees and radians?
Yes.
And how many radians was a half circle? Do you remember?
Pi over 2.
Close. I wish it's a half of a circle. Wouldn't it be nice if it was pi over 2? You should go watch the recreational mathematician Vi Hart, V-I-H-A-R-T, on YouTube, and see her bitter diatribe on why pi should not be a thing, tau should be. Because if you were like, a half circle is a half pi, that would make sense. You would relate with her. But, sadly, 1 pi is a half circle, 2 pi is a whole circle. It could also be a 0 and just not have ever started. So you have 0, you have pi, and you have 2 pi. Which is why I like to think about pi, not as a piece of pie, because that goes all the way around, but it counts in. Why? Cows on one of those taps. And it's nice and full with gooey inside. But anyway, for those of you that have never tried a calzone, I am so sorry. Maybe we should have someone bring some for pie day. Anyway, calzones. Not until March we have time. So calzones, pieces that are folded, literally, it's a half circle. 1 pi, half a circle, in case you're curious, tau, isn't that a Greek letter? Is equal to 2 pi. So 1 circle, 1 tau. Half a circle, half tau. Fourth of a circle, fourth tau. By Hart's like, why not make tau a thing? Why pi? Anyway, coming back. But what did pi actually mean? What is pi as a number, guys? 3.1415926, etc. I remember that because one year it was March 14th, 2015, and I had the kids take a picture at 9:26 in order to get extra credit, and it was on a Saturday. It was actually quite fun. But coming back, do you see how there's like a 1 radian here, and a 2 radian here, and a 3 radian here, and then you have like a little bit of an extra, 3.1415926. And 4 radian, 5 radian, 6 radian, a little bit more. 6.28. I want you to imagine a ruler that's blank. No units whatsoever. Throw it out the window. No units. Just a ruler. Let's make it a flexible ruler. Ooh, this one's flexible. So what if I was to totally paint over this and it was just a blank ruler? No units. Okay? And you were to give me any circular object. What's the closest one I can see? The paper towels. Okay. Any circular object, whatever size, small, big, I don't care. Okay? And if it was possible to find the center of the circle, come on, I have some fingers out there, I know I do. How could you find pretty precisely the center of the circle?
Put the ruler on. Oh, but you don't have measurements.
But where is it?
Go to the middle and draw on the ruler.
But how do I know that the ruler's in the center? The general what? How do you find it?
Put it in the middle.
Didn't you start taping strings? What would happen if you kept on taping strings? Wouldn't they all intersect at one point? Hey! Oh, stop. Just saying. Okay, so if you were to find the center, I'm just saying you could, right? If this was a lab and you were supposed to find the center, you just start taping strings or taping lines. Okay. We would find the intersection point, and that's the center. True? If I was to find the center, and if I was to measure, sure, why not, with inches or whatnot. If I was to measure the radius, actually, you know what? I wouldn't even need to measure the radius. If I was just to, and I have to approximate this because I didn't do the cool stringy thing, that would have been nice. Smart. Okay. The diameter goes all the way across, true?
Yeah.
Okay. And I would actually have to go from the end of the tape to the other end of the tape. And I need some sort of colored expo. I should have plenty to choose from. Let's do a piece measure. Remember, blank ruler. Inches, centimeters, millimeters are all out like that. Radius only goes halfway, true? Okay. So if I was to measure this, hey, it's 4, but that's not perfect. Okay, dead piece of Ready? That's 1 radius. Good? New ruler. 1 radius. Where's 2 radii? Where would 3 radii be? Can I just keep going and keep measuring it, right? 3 radii? Where would 4 radii be? I don't want to go that far. I'm going to lose my reference system. About there? Oh, guys, is this approximate? Yes, I don't have my strings, but it's a nifty little center, and I kind of eyeballed where to put the center. But have I just made a new ruler? What are my units? Whose radii? This guy's. If I had a different circular object, what would change? The size of my radii, right? But isn't that 1 radius, 2 radii, 3 radii, 4 radii, 5 radii? Actually, technically, sorry. 1 radii, 2 radii. I ran out of space for the last one. 3 and 4. Okay. So, how does that relate? Any circular object, you might just need longer rulers if it's a huge one, right? What's going to happen if I start at the beginning and start measuring around? Now, once again, it's going to be approximate. How many of these tick marks is it going to take to measure half? How many radiuses? There's 1, there's 2, there's 3. Halfway is right about here, and it's 3 and, check my finger, a little bit. Guess what's always going to happen? 3 and a little bit. Guess what the little bit is always going to be? If you have supercomputers, it's going to be pi. Wait, every time? Every time. Blank ruler, take a circular object, find the radius, make new ruler marks of radiuses, and wrap around. Always 3.1415926 to go halfway. Guess how far to go all the way if I had a long enough ruler? 6.28. I don't have those ones memorized. ... All the rest.
Wait, which one is that?
2 pi. 2 calzones. So what's a radian? It's a radius wrapped around. Hey. P.S. What was the name in geometry of that length that wrapped around an angle? Almost. Circumference is what you're thinking, right? Perimeter of a circle is circumference. Arc length used to be a thing. Do you remember how I said ignore all the inches and centimeters and all that jazz? If you were actually measuring, would you be ignoring all the inches and centimeters and all that jazz? No. You would say, like, what is the radius? 4 inches. Actually, my radius was... I started at the edge of the ruler, so now I don't know. I would approximate 2 inches. My radius was about 2 inches. So if I measure with inches or centimeters or something else besides radii, and if I find the ratio of what the total arc length is, the distance around whatever angle it is that I'm measuring, and this one they showed theta to be right here, it looks to be about 1 radius. But if I was to measure that in inches or centimeters or feet or miles or whatever I need to for whatever distance or size this circle is, and if I was to divide that by the radius, I would always get the angle in radians, which might just barely start to explain why in calculus, our calculator is always going to be in radians. Radians are naturally occurring. Degrees are a man-made construct to make it make more sense. But 90 is 1 a little bit. I don't know. 90, the smaller degree marks let you be more precise and land easily on this right angle, whereas radians is kind of an awkward ratio. That's actually a decimal. Unless you think of everything in terms of pi. If you think of everything in terms of pi, 90 is not that hard. It's just half of it, and so it's pi over 2, or 1/2 pi. Now, some of you are having kind of horrible flashbacks to last year, being like, oh yeah, we had to know who was who and what was what in radians. Degrees was so much easier, 90, 180, 270, 360. Come on, some of you got stuck on degrees down here too. But, long story short, radians are actually easier to think about in context of the actual circle's size. Let's see if I can make it make sense. So, if you're measuring all the way around a circle, 1 revolution, which is the way we could actually use it this way, right? The perimeter of this circle, or we could also say the circumference, right? But if they're measuring the circumference in some other unit, like inches or centimeters or millimeters, well, if they're measuring it, we're going to have to divide it by the radius to say, okay, how many radii would that be? So if it's measured not by radiuses, not by a blank ruler that they made with the radius itself, okay, fine. Then if I just divide it by the radius, I'll know how many radii would have gone into that. 1 revolution is 2 pi, remember? Half a revolution, so that'd be all the way around the circle. Half a revolution, that's just 1 pi. So what would a 4th revolution be? Take half of that, pi over 2. Why don't we write it 1/2 pi? Well, it starts to get kind of tricky because then the fractions take up space. So instead of writing 1/2 pi, we write it pi over 2. So what on earth is going down here or going on down here with things like pi over 6 and pi over 4 and pi over 3? Well, in geometry, way back in geometry, didn't you guys learn there were special angles like 30s and 45s and 60s? Yeah. And those special angles had special ratios? Why does 30 go to pi over 6? Why does 45 go to pi over 4? Why does 60 go to pi over 3? Well, hold on. If pi is half a revolution, what was that in degrees again? All the way around, 360? Halfway around? 180? Quarter way around? 90? So can't I say the easiest conversion? Ooh, hey, dimensional analysis. Build bridges to get rid of what we don't want. Can't we say that pi with an understood, this is where it gets weird. Radians aren't usually written because once again, they're naturally occurring. All of these have understood units that we barely ever write. But we could say pi radians equals 180. What? Because 3.14 equals 180? No. But pi radians equals 180 degrees. 12 inches equal 1 foot, right? 5,280 feet equal 1 mile. Not because the numbers are equal, but the amounts are equal. Okay, coming down. So, what would 1/6 of 180 be? Is it 1/6 of 180 at 30? Oh, these are going to be little 30 degrees. What's 1/4 of 180? 45. What's 1/3 of 180? Okay, these are easy ways to remember. Oh, hey, this will go with 60s, this will go with 45s, this will go with 30s. But even beyond that, do you guys ever struggle with figuring out what each of these little angles are supposed to be measured by? If you think of pi as being a calzone, if you're cutting it up to share with 6 friends, and if you have 2 slices, how much do you have? 1/6 plus 1/6 is 1/3, or 2/6, right? Oh wait, that's a pi over 3. Okay, forget that. Hold on. Maybe he has his own little thing over there. 1/3 is 2/6. But what would this angle be? If you have all but 1 slice, you cut it into 6. You've had 1/6, 2/6, 3/6, 4/6. Who's this guy be? 5/6. Oh, that's easy. It's just, if pi is 6 pi over 6, if it's a calzone cut into 6, just take away 1. Wait, that makes this guy easy too, because you have all 6 and 1 more. So what would this one be? 7 pi over 6. Hey, that makes this one. What do you get there?
Pi over 3.
That makes this one easy also, because it's all 12 slices, take away 1. Guys, unit circle is literally just fractions.
Never explained it.
Just 6 slices of calzone. Never had a calzone? We need to educate you. So, we have all 6 slices. Just think of pie if nothing else. Pumpkin pie, it was sold yesterday. There you go. All 6 slices, take away 1. You have 5. Add 1. You have 7. All 12 slices, take away 1. You have 11. No big deal. So guys, what would this one be if it was cut into fourths instead? We have pi over 4. But what would this one be? 3/4, because it's 3 of the 4 slices. Because this is 4 pi over 4. Where would this one be then? 5 pi over 4, because you have all 4 and 1 more. What would this one be? Well, all 8 take away 1 would be 7 pi over 4, right? It's just addition and subtraction of fractions. So then, who's this guy? 2 pi over 3, because you have 2/3, right? This would be 3 pi over 3. Where would you be down here? 4 pi over 3. 5 pi over 3. which you could just add this way, or you could take 6 slices, take away 1. It's all fractions. So then if that's 1/2, 1/2 plus 1/2 is 1 whole. Oh, he's over there. What if you're down here? Don't you have 1.5 calzones? I know it's silly, but if hey, remember, up here a second ago, wasn't half the battle figuring out where the angle was? You have to figure out the sine, the cosine, the tangent, the cosecant, the secant, the cotangent, the SOHCAHTOA, and the TOHCAHTOA. But can you figure out where the angle is? So if I put that same cosecant, 11 times? I think there was an 11, but I think it was down here. Why did I say that was in the second quadrant? Oh, because it's almost a whole calzone. It was just a little baby 6 off. Does that make sense? So it's all 6 slices. Oh, take away 1. No big deal. Now, I also think about this in terms of special geometry triangles, because if I can figure out that this is or relates to somehow a 30-degree triangle, then I can be super snazzy and say, wait a minute, there are things I know about 30, 60, 90, like across from 30 is a ratio of 1, across from 60 is a ratio of 1, 2, 3. Couldn't we then do SOHCAHTOA and find anything you want? Like sine is 1/2, cosine is, oh, wait, I'm going to the left. There's a negative. Cosine is adjacent over hypotenuse, tangent with the opposite over adjacent, and then my TOHCAHTOA would just be flipping all of those. Wait, he flipped somebody. Who did he flip? He was the reciprocal of sine, which is opposite over hypotenuse flipped, or CHO, hypotenuse over opposite. That's how I got mine too. Mickey.
So the calzone, I hate 180.
Yeah. Because it's a pizza that's been folded in half. And then like, you never had a calzone? You're one of those? It's okay, you're cute. Let me freeze the screen, because whenever you search on YouTube, you never know what's going to come up. Stand up. What are we doing? Oh, coterminal angles? What are those? Complementary, supplementary? What is that? Okay, do we have a couple more things to do? Yes, but what is a degree? A man-made construct to make things a little bit easier, but it's actually not really naturally occurring at all. So what is a radian? A radius measured around. Bye, guys. Yes, I think you can start.
Homework. Do we have an essay? Friday.
For what?
Yeah, we have outline.
It's Friday?
Yeah. No, the full thing.
So we have
this homework. Yeah, we have this outline, the intro, and then magically on Friday everything's done. We have a What's on? He's like, okay. He didn't even. The problem.
Don't throw it.
You know what?
That is your fault, and you will have to
If you
put
can.
it together.
No, I don't.